So we just learned about how glucose can be broken down into its component elements, carbon, hydrogen, and oxygen, and how those elements can be used to form smaller molecules like water, or also put together with other elements like nitrogen to form proteins. So glucose and proteins and water are some examples of compounds, but there are actually countless numbers of different compounds that exist in our world, and they're all determined to be organic or inorganic. At this point, I'm going to discuss the information on this note sheet in your packet. Please make sure that you have your note sheet open so that you can copy down the notes that I'm writing and or any other things that you find important. Pause the video while you get that set up. Okay, so on this note sheet, again, we're going to talk about how different compounds are divided into two main categories, organic and inorganic. One of the ways to remember organic compounds that I learned a long time ago from a student teacher was to call them organic compounds. And this CHO reminds me of two things. First, it reminds me that they're repeating chains, CHO chains of smaller molecules, meaning organic molecules, if it percent is like a carbohydrate, would be small pieces of glucose all chained together. As you can see, here's a glucose, here's a glucose, here's a glucose. To make a carbohydrate, they chain together almost like a train. Okay, we're going to learn 4 different organic compounds that can do this. Another reason why CHO is helpful is because organic compounds have to have carbon, hydrogen, and oxygen in them. So if we write this here, carbon, which we call C, that's its abbreviation, hydrogen, and then oxygen. Oops, capital H is how we always delineate these elements. Get some space here. And then our last one will be oxygen, which is O. So you can see that organic compounds, or really our organic compounds, have chains of repeating molecules. So they're usually big molecules with small molecules that making them up. And they have to have carbon, hydrogen, and oxygen, hence the CHO, carbon, hydrogen, and oxygen. There are actually 4 types of these organic molecules: carbohydrates, proteins, lipids, and nucleic acids. Carbohydrates are a chain of pieces of glucose. So we know that glucose is C6H12O6. So it has carbon, hydrogen, and oxygen. Carbohydrates are chains of that, so they definitely have the CHO component of organic molecules. In carbohydrates, there literally is C, H, and O. So that's one type of organic compound. We'll do this last column afterwards. Proteins are actually made up of pieces called amino acids. This is going to be something that you're going to need to remember. We're going to be learning it in later units as well, relearning it. But proteins are long chains made up of pieces called amino acids. So it'd be like if you had a bunch of beads, you would have one bead as amino acid, the next bead is an amino acid, the next bead would be an amino acid, and all together they make up a protein. Now, proteins have carbon, hydrogen, and oxygen, which is required to be an organic or organic compound, but they also have nitrogen, and sometimes they even have other molecules like sulfur and things like that. Oops. Lipids are chains of glycerols and fatty acids. They only have carbon, hydrogen, and oxygen in them, just in different quantities than carbohydrates. Actually, carbohydrates, if you eat too many carbohydrates in your diet, they will be stored, they'll be rearranged and stored as lipids or fats. So another word for lipids is fats. Okay. And then if you are on a diet and you don't have enough carbohydrates in your body, the fats will be rearranged, turned into carbohydrates, and then used. The final one are nucleic acids. Nucleic acids are also organic compounds. They're made of something called a nucleotide, which we'll get into much more in depth in a later unit. But nucleotides are made up of carbon, hydrogen, oxygen, nitrogen, and phosphorus. So again, you can see that carbohydrates, proteins, lipids, and nucleic acids are all organic or organic compounds because they have carbon, hydrogen, and oxygen at least in them. They can have other molecules added to them. In terms of jobs in your body, carbohydrates, when you eat things like sugars and pretzels and starchy foods like potatoes or pasta, those are made and used to give you quick energy. So carbohydrates, usually intake them and then use them immediately to help you make quick energy, which we will talk about as our next topic in this unit. We use these CH&O carbohydrates to make ATP, which is our energy, in a process called cell respiration. Proteins, C, H, O, and N, is another organic compound, but these ones have lots and lots of different jobs. I'm just going to list a couple. They're structural. That means like all of your different body parts, your bones, your skin, your muscles, your hair, your eyes, all the parts of your body are actually proteins. They also have a job in speeding up the reactions in your body. Most of the reactions in your body would happen so slowly that you would not even know, you would not have them happen fast enough to stay alive. So proteins called enzymes make that happen. Some of them, all the pigments or colors in your body, your hair color, your skin color, your eye color, those are all because of proteins. So as you can see, proteins do many things. They also send messages. There are things like receptors and hormones and neurotransmitters, and they fight the foreign invaders. So they're also a part of your immune system. Again, all of those things we will learn later. I just wanted to have you realize how many parts of your body are proteins and how important they are for you. Lipids and fats are more like a stored energy, and nucleic acids are how we have our hereditary, if I can spell correctly, hereditary information. They're the directions in our body. Things like DNA, which is deoxyribo, Na stands for nucleic acid specifically. So these are the 4 organic compounds: carbohydrates, proteins, lipids, and fats. They all have CH and O. Some, like proteins and nucleic acids, have other additional elements. They each have their own job, but as you can see, they can each be broken down into their smaller pieces, and then those pieces can be rearranged to make each other. Carbohydrates can be used to make proteins. Carbohydrates can be used to make lipids. Carbohydrates can be used to make nucleic acids. Nucleic acids can be broken down to make carbohydrates. There's all different ways that they can be rearranged. Other molecules in our body that are inorganic, meaning in front of a word means not. So not organic compounds. They can have carbon or hydrogen or oxygen, but they will not have all 3 at the same time. Some examples of things for this would be water, which is H2O. It has the hydrogen and the oxygen, but does not have the carbon, so it's not organic. Another would be carbon dioxide. It has the carbon, the oxygen, actually 2 oxygens, but it does not have the hydrogen. Others, like oxygen, has the oxygen, 2 of them, but no hydrogen or carbon. So as you can see, if I spell water correctly, each and every one of these, and others, some have none of the things, like iron would be Fe, would have no carbon, no hydrogen, no oxygen. If it doesn't have all 3, we call it not organic or inorganic. So there's 2 choices. They're either organic, or they have CH and O, and these are the only 4 organic compounds, and these are what they're made of, or inorganic, such as this. So what I want you to do now is take some time to work on the next page. Try it on your own. Give yourself a chance to go back and forth with the information, and then complete the related questions that have been placed on the Google form. And invaders is spelled with an E.